All right, let's take a look at this one. What I would suggest to do here is to first replace these square roots with the power of a half. So the root of x plus 2 becomes x plus 2 to the half, and x minus 1 square root becomes x minus 1 to the half. And since both of these are a power of a half, we could write this with big brackets in the following way. And I think this is the way to, I think it's in a good position now to start using the derivative. We'll use the chain rule. So we're going to ignore this quantity that's inside the power of a half at the beginning. So the derivative of that would be what? Well, if you have u to the power of a half, or anything to the power of a half, the half comes out front. The thing that we're ignoring stays still. We have a half minus 1. And then we multiply by the derivative of what we were ignoring. That's the chain rule. Let's fill in the things that we were ignoring. So that's coming along. Now this derivative is easy. It's just a simple application of the quotient rule. Let's do that. I just recopy this part over here. A half minus 1 is negative 1/2. So what's the derivative of this? Well, the quotient rule says we first do the derivative of the numerator. The derivative of x plus 2 is just 1 times the denominator left alone, minus, now we leave the numerator alone, and we multiply by the derivative of the denominator, which is 1. And then on the bottom is the square of the old denominator. Good. So we're done the derivative now. There's no more derivative signs, so we're done. But we do need to simplify it, I guess. Let's see what happens. When we have a negative 1/2 here in a fraction, we can actually just flip the fraction, take the reciprocal of it, and then this becomes now a power of positive 1/2. What about here? Well, this 1 is really not doing anything. So it's 1 times x is still x, 1 times 1 is still 1. Same with this 1, it's not doing anything. This minus in front of the brackets, we'll distribute that across. So it'd be minus x minus 2. And the bottom stays the same. Now what's going to happen? Well, those x's cancel. And negative 1 minus 2 is negative 3. So let's see what happens. Let's clean that up. And what I'm going to do here is I'm going to go back and put the power of a half separately on each one again. Remember at the beginning how we, at the beginning they were separate. There was a power of a half here, and then we made it into a single power of a half. I'm actually going to go back to what we had before now, because you'll see why in a second. It's going to be useful in a moment. So what happens over here? Well, like I said, those x's cancel, and we have a negative 1 minus 2, which is negative 3. And then we have x minus 1 squared. Now, the reason I separated those powers is because here we have a power of x minus 1, and here we have a power of x minus 1. We can combine those. Maybe I'll just go slow a little bit. Let's write this as a single fraction, okay? Negative 3 times x minus 1 to the half is what goes on top. And on bottom, I have 2 times x plus 2 to the half over x minus 1 squared. I'll just go over here. The powers of x minus 1 here are common, so we can subtract those exponents, right? We get a half minus 2. X minus 1 to the power of a half minus 2. What is a half minus 2? Well, it's negative 3 halves, right? So negative 3 halves goes up there. And the bottom is just staying as this. And why don't we just do one more step to get rid of that negative exponent? Oh, sorry. I just want to erase this. So our final answer, I think we could write as follows. Negative 3 on top all over 2 times x plus 2 to the half times x minus 1 to the power of 3 halves. And that's our final answer.